Okay, guys, this is Dr. Edwards again. Guess what I'm going to do? I'm going to give you some hints about the first set of exercise questions, 1 through 10. So, what I'm going to do, I'm just going to read the questions and I'm going to give you what my answer would be for each of them. I'm not going to write the answers. I expect you to be able to listen to my presentation here now and read the material that I have put online. And I think you should be able to write your answers in comparison with mine. Now, you know, when you do your homework, you're supposed to, in this case, write out each question and then right beneath the question, you write the answer. Then you go to the next question, you write the answer. You write the question, then you write the answer, et cetera, until you finish. So there will be 10 in this sequence. Then you scan them all into a single file. You may use your cell phone to scan them into a file. Then you upload them to the where you receive these questions. You can upload them right there. The first question, the conversion of water to ice is considered a physical change, whereas the conversion of iron to rust is considered a chemical change. Why? When iron as an element is converted to rust, there is actually a process that the iron has gone through. It has mixed with water in the presence of sunlight, and we have an entirely different substance than what we started with. We started with just iron, but because it's a chemical change, we end up with a substance that's totally different than what we start with. Whereas the conversion of water to ice is merely a physical change. There is no change in the H2O molecules. They just now the molecules are in the water state as opposed to the ice state. That's my answer. Number 2, how can you show that water is a compound rather than a homogeneous mixture of hydrogen and oxygen? One way that you can do this is to go through a chemical process to decompose water into hydrogen gas and oxygen gas. When you do that, if you're a chemist, you can take the ratio of the mass of the hydrogen gas to the mass of the oxygen gas, and it will always occur in a definite ratio. That's one way that compounds differ from mixtures, where mixtures you can have any different combination of the constituents, but a compound, they all will always have a definite ratio by mass of the constituents. Number 3, heat is a physical process. When mercuric oxide is heated, it becomes mercury and oxygen. Does this mean that mercuric oxide is a mixture rather than a compound? No. Mercuric oxide is clearly a compound. You will always have the definite ratio between hydrogen and oxygen that go into making mercuric oxide. Although it's a physical heat is a physical process, it too is a chemical process. It will drive chemical changes. Number 4, which of the following substances are homogeneous and which are heterogeneous? The substances are blood, carbon dioxide gas, solid carbon dioxide, rock, steak, iron, rust, concrete, air, oxygen, salt, and milk. So you can just write the answer to these. You write homogeneous, heterogeneous, and you list underneath each. For me, blood is essentially homogeneous. It is consistent throughout on the microscopic scale. So I put blood in the homogeneous category. Let me also say that all elements and all compounds are always homogeneous. Therefore, carbon dioxide gas, which is a compound, is homogeneous. Solid carbon dioxide is just another form of carbon dioxide. It is homogeneous. Rock, on the other hand, you will find as we study rocks later, they have different constituents of minerals, etc. present. So that rock will be heterogeneous. Steak. If you examine steak, you're going to find some fat, a great deal of proteins. You'll see perhaps some blood vessels, etc. Therefore, steak visually is a heterogeneous substance. Iron is an element, so iron is a homogeneous substance. Rust, a little bit on the edge, not quite. We differ as to whether rust should be a homogeneous or heterogeneous. But I'm going to put rust in the category of heterogeneous. Concrete, if you examine concrete at your parents' house or somewhere in the neighborhood, you will find that it has cements, it has rocks, it has other substances. You can clearly tell that it's not homogeneous all the way through. Therefore, concrete is a heterogeneous substance. Air, the air in the room where you are right now, is clearly a homogeneous substance. Oxygen is a element, and therefore is homogeneous. Salt, also homogeneous. Milk, if you look at it clearly, it is for the most part homogeneous, okay? Number 5, which of the following homogeneous liquids are elements, which are compounds, and which are solutions? The substances are alcohol, mercury, liquid, hydrogen, pure water, seawater, and beer. So the question is, which of the following are homogeneous liquids, or which of the following homogeneous liquids are elements, and which are compounds, and which are solutions? Alcohol, you will find, is a homogeneous liquid that is a compound. Mercury is a homogeneous element, homogeneous liquid that is an element. Liquid hydrogen is a homogeneous element. Pure water is a compound, so that's a homogeneous compound. Seawater is a mixture, and beer is also a mixture, okay? Number 6, how does the law of definite proportion help to distinguish between a compound of certain elements and a mixture of the same element? So this is the way I express that. This law of definite proportions states that elements will always combine in a definite ratio by their masses. Whereas if you have a mixture, you can mix any amount of the constituents that go into making that a mixture. So if you have a substance and you want to verify whether it's a compound or mixture, you can decompose it. And when you decompose it, you will find that it has a definite ratio by mass of the constituents. Therefore, you can say unequivocally it's a compound. Number 7, what is the most abundant element in the universe, in the entire universe, in the human body? The most abundant element in the universe, young people, is hydrogen. That is the most abundant element. Why? Because all the stars are made of hydrogen. Our nearest star, the sun, 93 million miles away, it's largely hydrogen, and it's a regular process where hydrogen it is converted into helium, and that causes the sun to liberate its energy. But hydrogen then is the most abundant element in the universe. It is the smallest and the simplest element, but it's the most abundant. In the human body, it is oxygen. Oxygen is by far the most abundant element in the human body. Number 8, what kinds of particles make up gaseous compounds, liquid compounds, and solid compounds? So the type particles could be molecules, atoms, and ions. So for gaseous, it can only be one to be a compound. It can be only molecules. For liquid compounds, it could be molecules, atoms, and ions. I-O-N-S is the word, ions. And for solid compounds, it can also be molecules, atoms, and ions. Number 9, the formula for liquid water is H2O. For solid, zinc sulfide is ZNS. And for gaseous, nitrogen dioxide is NO2. Precisely what information do these formulas convey? And what information do they not convey? These formulas, and all formulas, young people, convey what the ratio between the constituents. So H2O says that there are always 2 hydrogen atoms to 1 oxygen atom in water. Or for nitrogen dioxide, there's 1 nitrogen atom to every 2 oxygen atoms, etc., etc. And 1 zinc for 1 sulfur. What they do not convey is how difficult it is to produce these compounds, or what's the yield factor. How long does it take you to produce them? So the formula merely indicates the ratio, I say again, but doesn't say anything about the yield factor or the difficulty in making them. The last one is what is the difference in meaning between C sub 4 and 4C? So I'm always asking this kind of question on my examinations too. So C sub 4, that subscript, indicates that there are 4 carbon atoms. C represents carbon. So C sub 4 is 4 carbon atoms combined. Where 4C, where 4 is the coefficient, mean just 4 carbon atoms. They are not necessarily combined with each other, okay? All right then, guys, I've given you my hints. This is a hint for doing your homework. I expect everyone to have their homework for this particular portion of chapter 10. And I have some more homework to give, but you go on and get these 2 in. I'm going to have these due early part of next week. That's all. Have a good day now. Bye-bye.